How are you guys? Welcome back to my YouTube channel. Today we are still under strength of material N6, right? We'll be dealing with combined bendings and twisting of shaft. But firstly, remember now we'll be dealing with combined bending and twisting. You see, this is a combined bending and twisting whereby before we'll start by taking some overview. By overview meaning like we'll check first the revision. We'll do a quick revision firstly before we can get to the one that we know, the one for N6. We'll check, we'll overview what we know, guys. Some revision. So we have combined bending and twisting of shaft module 3 overview of module 3. When you have completed this module, you should be able to unit 3.1 to determine the maximum torque, calculate maximum torque transmitted by motor using power formula, including percentage increase due to the starting torque, calculate the maximum torque transmitted by belt drive with the belt tension, calculate maximum allowable torque can be transmitted by solid or hollow shaft, calculate actual shear stress in solid shaft, calculate dimension of hollow and solid, calculate the weight of the pulley, centric loaded or shaft when it's simply supported. In this topic, is what we're supposed to know. Then unit 3.2, the maximum bending moment, calculate the bending carried by shaft using the standard formula used for cantilever. Okay, guys, all of these. Unit 3 is equivalent torque and equivalent bending. We'll see these guys. We'll see all of these guys. So these are shafts. For revision, the shaft is okay. For revision, here are some formulas that we're supposed to be familiar with. For a quick revision, we have some formulas that you should be familiar with. The imported formulae, maximum torque is equal to T mean into 1 plus over load over 100. This is measured in Newton meter. Then the power formula, check here. We are not using the maximum torque, but we have used T mean there. We're using T mean, not maximum torque, guys, as you can see there. All right, check there. This is T mean, this is maximum torque. We're using, when you're calculating power, we're using T mean there. So by the way, another formula should remember, power is equals to force multiplied by velocity. We know this formula, guys. Know this. Here, calculating velocity, pi dn over 60. We know that the torque, you write T1 minus T2 multiplied by radius. We know this, guys. This is the torque. You must remember that. The saving mass, you're supposed to remember it's the area of the solid minus the area of the hollow divided by the area of the solid multiplied by 100. So, or saving mass, you're using the other second, the diameter squared of the solid minus the diameter of the hollow squared plus the inner diameter of the hollow squared divided by diameter of the solid squared multiplied by 100. You must know that formula. As you can see, saving mass, it's either using this or this. It's one and the same thing. Me, I can prefer this. Remember the area, because okay, this will be pi over 4d squared. Here solid, not minus pi over 4. I can say d squared. Yeah, hollow over pi over 4 d squared. Yes, solid pi and pi. Take out this as a common factor. If you take out pi and pi will cancel. So you can write that as d squared of the solid minus the diameter squared of the hollow over, you see what I'm doing there, over the diameter squared of the solid. You can use this formula. I've reduced. See, simple, just like that. So okay, since this is an overview, this is a revision. Let's check the formulas. This section is a revision. This section is a revision of N5 and deal only with shear stress. In shaft, dealing only with shear stress, not the twisting of an object applied. Remember now, we're dealing with a shear. All right, here it's our imported formula. There you see, torque over J, which is polar moment area, is equal to shear stress over radius of curvature. This is a torque over polarity, shear stress, radius of curvature, G, modulus of rigidity, angle of twist in radians is measured the length of the shaft. As you can see, this is measured in radians. Must remember that this in Pascal, in meter. The polarity in meter raised to the power 4. Shear stress in Pascal. Torque, yes, you know, torque is measured in that Newton. That, so remember then this J, polarity of moment of area, is pi over 32 multiplied by d raised to the power 4. It's measured in that. All right, so J again can be given by pi over, if it's a solid, remember this is for solid shaft. If you're given a hollow shaft now, given hollow shaft, you have pi 32, you have d raised to the power 4 minus d raised to the power 4. Obviously still measured in that, but this is for hollow. If you have given hollow, that is what you will use. This is just a review, guys. Supposed to remember this. It's a preview. All right, let's take this preview here. We have says calculate. We have our preview. Still have this preview. Says we have given example 3.1. Says calculate the maximum torque transmitted by motor using power formula and calculate the shaft dimensions. You see, and calculate the shaft dimensions. So, by the way, okay, want them calculate the torque, want the torque transmitted, obvious, the torque maximum torque, want the maximum torque there, and the dimensions, whereby the diameters, we want them. Okay, I've given that the hollow shaft with a 3/5 diameter ratio, all right, is required to transmit 800 kilowatts at that rate or that speed, which is 200 rests per minute. The maximum torque exceed the mean is this. Maximum torque exceed the mean is 15%. The shear stress is not to exceed 800 or 80 megapascal. That is the shear stress. And the twist in the length, or is in a length of, that means the shaft has the length of what, of simply of 4 meter, is not exceed what, 10 there, Alright, we'll see that says calculate the internal and the external diameter, certifying this condition you've given G, which is 70 there, modulus of rigidity. So this is what we have. Alright, so by the way, we want the power. Alright guys, we want the torque, so we should calculate the torque. We have given the power here. As you can see, we are given the power. So by the way, power it's equals to what, right? Is 2 pi n t mean. I've discussed that this is a mean. We have seen this in our formula. Divide by what? By 60. If you have forgotten, check here. I've discussed about this formula here. You see, I've shown you. Here it is T mean. See the torque, it's a mean torque. You see it's a mean torque there. Alright, that is a mean torque. So that is a mean torque, by the way. So this is what we have, Mr. Mean torque there, by the way. Sorry about this. Oh, sorry about that. Okay guys, the power we have the power we have there. You see it's 8. I've circled it. It's 800 there. The power we have, the power is in it. So power we have, which is 800 kilowatts, which is says times 10 to the power of what, of 3 equals to 2 pi n. Speed there is 200, as you can see there, right? We have 200. T mean, we don't know about the mean torque. Don't know about the mean torque. Divide by 60. Then can calculate T mean. Okay, you will multiply this side by 60. All right, then I divide by that. So okay, you'll see I multiply that will be 8 times 10 power of 3 multiplied by 60 is equals to 2 pi times 200 multiplied by what T mean. All right, this is what we have, isn't it? So this is what we have. All right, so by the way, now we can divide by 2 pi 200 both sides. 2 pi, this will nicely cancel, and also this will nicely cancel there. Therefore our sorry guys, what I'm doing there, this cannot cancel. What I'm doing here, it's a mess, right? I did a mess. This cannot cancel, isn't it? Just punch that on the calculator. This one is only one that will cancel. Therefore find T mean. Punch this on our calculator. Supposed to get this to be 197,2. This is measured in Newton. Newton meter, isn't it? is measured in Newton meter. Alright, so we have that torque, but we are not done. Remember, we're supposed to have our maximum torque. There it says calculate maximum torque, not determine. So we want the maximum torque. Tmax. We've discussed about this formula. We've seen this formula that says Tmax equal to Tmin into 1 plus the load using percentage load. Talking about the overload divided by nicely 100 here. Oh my god, divided by nicely 100 there. Divide by nicely 100 all over okay, we divide by 100 nicely, so like this. So Tmin, we've just calculated it there. We have 1. The load here, what is that? We've said the torque must exceed 15 per mean of what? That is 15%. You see that is measured in 50. Here we've given 15%. So that is 15%, by the way. We'll have our 15% here. You write 15 as it is. Remember, it's in percent. As you can see, you write that 15 as it is. Then you divide by nicely 100. Then it's a matter of punching all of this on your calculator. Punched all of that. Alright, punch all of that there. Isn't it? Yes, you punch that. You simply get this to be 43926 43926, 7 64 Newton meter. Alright, Newton meter. Then this is what you have there. That is our maximum torque. So what we're supposed to find there again, you can call these two. Sorry about that. You can call these two. Well, you're supposed to find the dimensions, isn't it? That means you want the diameters. So here, guys, you have to be careful. If we have the maximum torque, you must use your ratio. We have given our ratio here, where the ratio, we've said the ratio of the hollow shaft diameter is 3 into 5 diameter ratio, right? So as you can see here, we've given that 3 to 5. All right, ratio is fine. We have that. All right. Three to 5 ratio. You can say for designing strength, remember we are considering strength, which is the shear stress. We are considering stress. There is this one for graduality. Let us consider the one for considering the strength. this for design for strength. Remember, we have two there, things supposed to take into consideration. If you still remember, remember we've given the small diameter in ratio to be it is 3 over 5 into the biggest diameter is the ratio. This is the same as 0.6 d, right? So there's this formula. We must know this, guys. You must know this formula, guys. Hopeful. You must make sure you remember the formula that say mean torque over J, the one we've discussed, is equal to shear stress over the radius of curvature must be equal to the rigidity multiplied by the angle of twist, the length of the shaft. This is very important, by the way. You must remember this formula. So from this formula, we can simply equate this portion. We can equate only this portion there. Right, we can equate that portion. That portion says, because we have a maximum torque, remember this will be maximum torque, by the way. On this question, always this is maximum torque, but it won't be written on your formula sheet, but we know this is a maximum torque. And then you must know this formula by head. It's not given on your formula sheet. This is a maximum torque. All right. T max, so that you'll remember, over polarity of moment, then equate that shear stress over the radius of curvature like this. So we have the maximum, by the way, we have the maximum torque, the one we did calculate. Well, we've just we did calculate it. We did calculate it. Let me check, what do we have again? So now we have the stress. The shear stress, it's 8. All right, since it is 80, that is nice. That's nice. That's nice. We have 8 over 80. So all right, we had the talk whereby it was supposed to play around with this maths. It was 43926,764, the maximum one, over, we know this, we said that, remember we're dealing with the halo, guys. If we're dealing with the halo, this is pi over what, 32 into d raised to the power 4 minus, but now remember it's supposed to be, okay, no problem, it's supposed to be d squared, is right, small, the inner diameter, the one like that, but now we have it here. We'll substitute the standard space. Okay, let me just go about. We have d raised to the power 4. Shear stress is 80 times 10 to the power of what, of is megapascal. 6 divided by the radius of curvature. The radius of curvature, if you're given the radius of curvature, it's a diameter divided by 2. A certain length, it's a diameter. Remember, the radius of curvature there is the distance there of the shaft, like that. From there will be diameter divided by 2. When you're focusing on the cross section, yeah, you take the diameter divided by 2, like it's a y, it's a vertical distance of the shaft. Yeah, right, from the bottom to the top. You take it, then you divide it by what? By 2. That distance there, that row, right? Then you know the distance of this will simply equals to what? Focusing on the cross section, remember the shaft is like this. This is the hollow shaft there. The hollow shaft is like this. All right. Then goes like that. We are not focusing on the length, no. We're focusing on this height, the length, that is height, the height from there. It's a height, talking about y. Y is like that. It's y bar. Consider it as y bar. That means the distance from there until here, you divide that distance by 2 always. So we know the distance of that is what? Is a diameter. So it will be d squared. The radius of curvature is given by that. Let's say, for argument's sake, let's say you have been given a rectangle or square. You'll take this distance from there until there. Then you divide that distance by 2. That height divided by distance, that is the radius of curvature, right? So we have d over 2. All right, the aim now, check here. We said d, remember that we found that d into that ratio is 0.6d. So in where I see d, I will replace this there. So on the top was still here, or on the top I'm still having 43926,764 divided by pi over divided by pi over 32 into d raised to the power 4, then minus, where I see d, I replace that with 0.6d raised to the power 4, like that. So here we still have 80 times 10 to the power 6 divided by d over 2. All right, so let's check the maths here. Let's check the maths. Okay, I will multiply by can I invert, take this to the top, also take that to the top, right? Okay, just invert, that will be pi over 32. I take this to the top, d raised to the power 4 minus right raised to the power 4 into 0.6d power 4, like that, isn't it? So this we have the bottom, then I take that, what is in the top on the bottom. Remember, if take this on the top, also that this will come down. This is the math. I'm just taking the inverse like that. As you can see, it's equals to take that on the top, isn't it? All right. So then then I can multiply by this here, then I divide, then I multiply by again to cancel that. Okay, then I divide by this. Okay, let me show you pi over 32 into d raised to the power 4 minus punch this. Remember, this is same as 0.6 raised to the power 4 d raised to the power 4. All right, then multiply that. I just said I take this to the other side, will be pi, or will be d over 2 multiplied by 43926,764 yeah, all over 80 times 10 to the power of 6. The aim, then I divide again. Let me divide by this both sides. If I divide by that, that will cancel. If I divide by this both sides, then here in the bottom I'll have d over 2. So then the math there, what does it says? So here we'll be left with pi over 32 d raised to the power 4. Then punch this will be 0.1296, right, d raised to the power 4 into d over 2 is equals to 43926,764 all over 80 times 10 to the power of 6. So yeah, now let's go about the math. Now let's check the math. All right, so what will be your math here? Let me let me divide this. Remember, here is ms1. Just punch this there, divide by that. I'll have d4 minus 0.129 so have d4 0.1296 all over d, then I divide by that. This side again, if I divide by pi over 32 over 1 over 2, then trying to punch this on the calculator, we'll get 2,7 96 times 10 to the power of minus 3. Alright, this is what I have, guys. By the way, you subtract here. This is like terms there. Simply subtract. After you have subtract there, you divide by these. These are like 10. Using the exponents, just say 1 minus 0,1296. This will be 0,8704 d raised to the power 4 divided by what? By d. Still have this there. Okay, we know the rules of math. There is 3. It's the same as we have 1. This will cancel with the 1 there. We're left with 3. Left with 0,8704 d raised to the power of 3. 2,796 times 10 to the power of minus 3. By the way, then we know divide by this both sides. Then take cube root both sides. This will be 0,1476 meter. Then so about that, then you can multiply this by 1000. Let this round this to 3 decimal place. This is 0,148 meter. 1 this in millimeter, multiply this by 1000. Therefore this will simply equals to what? 148 millimeter. D will be equals to 148 millimeter. Alright, that is it. So guys, remember now we can, what is this? We consider the strength remain design for strength. What about for rigidity? Let's try and consider for rigidity. Now let's say for when you are considering rigidity, which is G rigidity. Let's check when now we are considering the rigidity. Right. Let us consider the rigidity. For rigidity. Is the rigidity or rigidity? Right, rigidity. What's wrong with this pen now? By the way, don't know, my pen is doing some nonsense now. Ish. Alright. With maximum torque all over J multiplied by this thing, by the angle of rotation over the length, isn't it? This is what we know. The torque we had the maximum 43926,764 all over this, which is pi over 32 d raised to the power 4 minus d raised to the power 4 is equal to this. It was 70 gigapascal times 10 power of right of 9. The angle, this must be in radians. We've given that, are we given this angle? My question that, are we given this angle? Let me check. Or we are not. There is no, cannot say 1/8. What is this 10? Let me check. If it is not the twist is 10. Okay, here is 10. We've given the twist 10. All right. Must be in radians. That twist must be in radians. Is in 10 degrees. This will be 57 divided by 3. Remember, when you have degrees, you divide by 57.3. Would be in radian. Want to be in radians, then divide by this length. I think is 4 there. I've seen the length there, it is 4. So now it's a matter of mathematics again. All right. This time just punch all of this on the calculator. Just punch all of this. Then I will punch this again. And yeah, you'll see the math that I'm trying to do there. Supposed to substitute there, but no, but it is fine. No problem. There were 43926,764 divided by pi pi over 32 All right, this is what is 44743 4,344, then will be d raised to the power 4 minus d raised to the power 4. Then I punch that again. 70 times 10 to the power of 9 multiplied by 10, 57.3 for the bottom. Typically a long value, I'll just write 3,54 times 10 to the power of 9. All right, then I will divide by this. Both sides. All right. This and that will cancel. Here I'm left with d raised to the power 4 minus d raised to the power 4. Then I punch that 3,054 times 10 to the power of 9 divide by 4,473 4,447 4,344. This will be 682, 56. All right, then here I have d raised to the power 4. Remember this, it's the same as 0,6. all right, raised to the power 4 like that. Or here we have d also. Then the same as 0,6 for d4. Now I punch this. Remember d and d is the same. I say same as 1. This is same as 1 minus 0,6 raised to the power 4. Remember, if you take out d raised to the power 4, if it's a common fact, yeah, then you'll be left with 682,56 divided by 1. Then let me just take the fourth root there. This and this will cancel. Same time and punch this on my calculator once for all. Put it all on the calculator. Shift factories to the power 4. 682 comma 56 1 minus 0,064. okay, 6 comma 599. This is what it's made. All right. Oh, 6 to the power 4 ish. This is the power 4 there. It's 5292 meter. All right, that is what we have so far, guys. So nevertheless, guys, thank you for watching, guys. Thank you for watching. This was a preview, actually, was a recap. So thank you for watching. And then if it is your first time watching my video, may you kindly subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. All the best.